But one of the first things I wanted to understand from you is, how can we look at combustion? As you rightly put, I mean, we have been toying with combustion for quite some time, but the scientific understanding of it is relatively recent, maybe a few hundred years here and there.
Sure.
So how would you look at the fundamentals of combustion? How would you characterize it? And if you can give us some practical examples of it first.
See, if you look at some of the practical examples of how combustion touches our lives, start off with the cooking stove.
Yes.
So something which is a mandatory requirement as far as urban living is concerned. So that is a place where you have either liquefied petroleum gas, or for that matter methane, which actually burns, and you have that heat which actually is used for cooking applications.
Right.
So that apart, we have multiple other applications like thermal power plants, very large thermal power plants. In fact, India still predominantly depends on thermal power for its power requirements.
Right.
So the thermal power plants are a very, very large area where a lot of combustion is harnessed usefully and benefits all of us. So another thing which we see right in front, but it's not very, very obvious to all of us, is the simple IC engine.
Yes, absolutely.
So combustion takes a center stage even there. In fact, inside the engine you have both the fuel and the air mixture igniting together. In fact, it's an instantaneous combustion where akin to an explosion.
Right.
So it's a small controlled explosion which actually takes place inside an IC engine, and then we are able to use that power and harness that power to drive the engine. Even the rockets, in fact, over the last few days, in fact, a couple of months, the television has been dominated by missiles raining from one place to the other. Now, that is also the fact that the missile actually traveled from one place to the other. Is nothing but a rocket.
Yeah.
So it carries the fuel, it carries the oxygen source. So some of the rockets which actually are intercontinental, they also travel to space where there is no oxygen, so they need to carry their own oxygen source. So these are the ones which actually then go. They are targeted in one or the other area. They fall onto one area, and then there is an explosion, which is also an uncontrolled one.
Yeah.
So it is not something that let's say we would say a controlled explosion. But it's an uncontrolled one. But still, these are the practical facets of combustion that we see on our daily lives. Very, very important that we find out the benefits of those.
Yeah.
And then start using them.
Yeah.
In fact, in my own experience of combustion over the last 30 years that I've been in the industry, most of them have been in furnaces, in air heaters, and in boilers. So today I would like to speak about quite a few of those aspects, which are going to be very different from the theoretical aspects of stoichiometry.
Right.
But nevertheless very important for the audience to know, so that we are able to then they are able to understand how practically the industry applications of combustion are going to be slightly different from the normal stoichiometry that we go ahead and read in our books all day long.
Yeah, right.